Hi guys, and welcome to the latest video in the production of materials topic. Today we're going to have a look at some of the reactions of ethylene or ethene. Make sure you can actually read it. Ethylene or ethene. Some questions, I guess, to consider in the context of these reactions. Firstly, why are we concerned about the production of ethylene? What can chemists actually do with ethylene, and how do we test for ethylene in the laboratory? Firstly, why have we spent so much of this first topic talking about ethene? Well, we've done that because ethene or ethylene is a very important molecule industrially. And that's partly because of its uses and partly because of its ability to be converted into a wide range of other compounds that are very important, and yet those processes can occur with relative chemical simplicity. Here is your ethene molecule, characterized by this double bond, this reactive double bond. And that's really the key to why we have such a range of different compounds that we can produce from ethene. The double bond is very reactive, very unstable, and so therefore a large number of processes can occur as that double bond breaks. One of the things to talk about is the area of greater electron density. A double bond is equivalent to 4 electrons being located in a very small region of space, very close together. Now, electrons don't like to do that, so that's one of the reasons why this double bond is so readily broken. Some of the reactions of ethylene that we can look at are those listed on this particular slide. You can see that each of these is an example of an addition reaction. That is, something is being added across the double bond. So in each case, we have a double bond breaking, and in the first case, hydrogenation is the addition of hydrogen. So that will simply put a hydrogen either side of the double bond. Halogenation, the halogens are fluorine, chlorine, bromine, iodine, etc. So if we were to add chlorine across, again, the double bond breaks, but this time we have a chlorine on either side. Hydration is the addition of water. This is going to be very important at a later stage too. When the double bond here is broken, we get, change that color, we get water molecules, so an H, and an OH forming either side of the double bond. And then in the last case, for polymerization, well, that's when we get things like polyethylene. So in this case, we have a certain number of these, and N, and they're going to produce an endless number of chains of each of these carbons where the double bond has been broken, and we now just have single bonds as the polymer is being produced. The polymerization process is good for compounds of low and high density polyethylene, but it's also useful for things like PVC and polystyrene and so on, and we'll look at some of those in a later video. So just to recap on these a little bit more, hydrogenation is the addition of hydrogen across the double bond. The product will be ethane because you're breaking the double bond and you only have hydrogens accompanying the carbons. And this requires a catalyst in order to occur. So the catalyst could be nickel, or probably more commonly platinum, even though platinum is expensive, or palladium. So platinum catalyst is often the easiest one to identify for the hydrogenation across the double bond. Halogenation, as I mentioned, are all of those group 7 or group 17 elements. So bromine, chlorine, fluorine, and so on. In this case, you get a 1,2-dibromo occurring. So remember that when we're adding, say, 2 bromines, one goes either side of the double bond. And so therefore it's a 1,2, never a 1,1. This reaction occurs readily and one of the ones that we've mimicked in the laboratory, and no catalyst is required for this one. When we look at hydration, that is the addition of a water molecule, the product this time becomes ethanol, and we need dilute sulfuric acid as opposed to concentrated sulfuric acid. And in fact, concentrated sulfuric acid will actually be able to reverse this reaction, but we'll look at that later on when we have a bit more of an in-depth look at ethanol. But hydration is simply the addition of the water molecule across the double bond to give you an H and an OH group, and that's the characteristic functional group for the alcohols. So this is ethanol. And polymerization is again something that we'll look at in a little bit more detail later on, but this is lots and lots of monomer units, lots and lots of individual ethenes being added together in order to produce a very long chain of monomer units that are known as a polymer. And the best group of these that we're probably most familiar with are the plastics and things like PVC and polystyrene and polyethylene. The various catalysts that are involved in polymerization reactions, but one of the most important is the Ziegler nanocatalyst, and that's for the production of HDPE. So here's a question, a big question, this one, 7-mark question from the 2006 paper. Analyze why ethylene is such an important starting material for the chemical industry, and in your answer include relevant chemical equations and a description of new materials and fuels that can be prepared from ethylene. When you're answering these sorts of questions, it's important to have a look, first of all, at the verb that you're being asked to include. So analyze is obviously a higher level verb. You're not just discussing something in terms of identification or a description. You're not even just explaining something to do with the different reactions that occur. You're trying to analyze why it is an important starting material. So we make the assumption that it is, and then we try and support that assumption by having a good series of arguments that support the fact that ethylene is such an important industrial chemical. Remembering that we need in our answer to include some relevant chemical equations, some descriptions of materials that are new, and also some fuels where we... So each year the board puts out a report on each of the HSC examinations, and these are worth reading sometimes because they give you a little bit of an idea about how the different students answered the question and any sort of tips or tricks or pitfalls that has seen other students perhaps not do as well as they could, or where the best students have actually focused their attention. So remember, the important thing about this one is we need to identify the uses of ethylene. We also need to identify some of the important chemicals that are formed from ethylene. And remembering that we need to make sure that we are including chemical reactions in our answer, you need to make sure that when you're saying things like hydration, that you have a reaction, a chemical reaction that has identified exactly what you mean by that. So you can use this as a structural or a molecular formula. It doesn't matter which one you use. It's probably a good idea if you are putting states in, but make sure that you include these equations because you've been told you have to, so we need to make sure that we are doing that. Same thing for addition polymerization, so whether you're talking about LDPE or HDPE or any of the others, so PVC, polystyrene. And obviously at this early stage we have actually discussed each of these compounds in class, even though they haven't appeared on this particular video, and they will in subsequent videos. It's important to be able to not just discuss or not just identify these products, but to discuss some of the uses that we put to the different types of plastics, and the fact that these are our new materials. And we had to identify some new materials. And so these plastics have replaced a lot of materials that perhaps previously we used or made from metals. But again, they've also created a few little issues of their own. If you are also looking at things like PVC, then obviously you want to talk about substitution reactions where we have, say, an ethene which becomes a chloroethene. And if I just sort of leave the other ones there with hydrogens there, this chloroethene then becomes the basis of the vinyl chloride or polyvinyl chloride polymer. Now it's important to focus on the presence of the double bond. The reactivity of that double bond, that high electron density, is what enables so many of the reactions that involve ethene to occur. And as we've mentioned before, a good answer is always going to include plenty of chemical equations to make sure that you are illustrating each of the chemical processes that are described. Setting out these sorts of long questions, these 7-mark questions ahead of time with just a little plan, even just some dot points at the beginning before you actually start writing, can help you to organize yourself, can help you to make sure that you include all of the important points, help you maybe identify which reactions, which chemical formula you're going to include, and to make sure that you haven't left any points out. Thanks for watching.